based on Martin's formula. So for broad gauge and meter gauge, for the transition curve, velocity can be computed by 4.4 square root of r minus 70, where v is the in kilometer per hour, r is the radius in meter. Similarly, for narrow gauge, velocity can be computed by 3.65 square root of r minus 6, subjected to maximum of 50 km per hour. For non-transition curve, velocity can be computed by 4 by 5 times the velocity of this for broad gauge and meter gauge, and for narrow gauge, the velocity is 4 by 5 times the velocity of this, and subjected to maximum of 40 km per hour. Safe speed based on the super elevation. So for broad gauge, it can be computed by 0.27 square root of Ca plus Cd into R. For meter gauge, V is equal to 0.347 square root of Ca plus Cd into R, and for narrow gauge, V is equal to 3.65 square root of R minus 6, where Ca is the actual Kent, can be computed by this expression, that is GV square by 127 into R, where V is the equilibrium speed in kilometer per hour, R is the radius of the curve in mm, and the value of G can be taken for broad gauge 1750 and for meter gauge 1057. Similarly, theoretical Kent can be computed by V max square divided